our next presenter, Dr. Leonidas Platanias. So I won't bother going through this lengthy bio, which is extremely impressive, but rather I will introduce him through a personal story. So 18 and a half years ago, kind of in the height of my career, while we were all doing well, we went to Greece for the interment of my dad, who had passed away. And as the funeral took place, and then we went to the to the hotel, Marianthi, my wife, who's here in front of me, says, I'm feeling something that's uncomfortable. So we came back to Chicago, and we went to Northwestern Memorial Hospital, where we both used to do our annual physicals, and she was diagnosed with breast cancer. She was 45. I, of course, all of us in my family, where you can imagine the level of anxiety. And the first thing that I did is I drove to the nearest monastery, St. John's Chrysostom in Pleasant Prairie, Wisconsin, and I prayed for Marianthi and my family. The second thing I did is I called around the hospital to get a date for for treatments, let's say, to make sure that we have the right oncologist. And I was given a few choices, and I chose a lady by the name of Virginia Kaklamani, Dr. Virginia Kaklamani, who treated Marianthi, looked after Marianthi for several years, 5, 6, I don't remember exactly, and she was wonderful. The anxiety level when you go through something like that is unimaginable. But the first thing you look to is God. The second thing you look is for the right doctors. And soon thereafter, I forget exactly, Dr. Platanias, the date, but Dr. Platanias came to Chicago to serve as chairman of the oncology department at Northwestern Memorial Hospital, one of the best hospitals in the country, and certainly for us, for my family, and especially for Marianthi, it has been godsend. Dr. Platanias is not only an incredible scientist, he's an incredible human being. So many people know him in Chicago, I would venture to say that he is one, if not the best known Greek individuals that contribute to our society in Chicago. And I very often get calls from people, both in Chicago, across the country, and even from Greece, when they have a challenge like that, to put them in touch with Dr. Platanias. And I am incredibly grateful to Dr. Platanias, because within 5 minutes, whether he is in a conference in London, talking to Dr. Fauci somewhere, I know they're friends, or in Hawaii on vacation, he calls me back within seconds. He has never refused to participate by phone or to give us the best advice and the best oncologists at Northwestern and elsewhere. I can go on, but somebody talked earlier about the general and humility. Obviously, Dr. Technos, we see that firsthand here. Dr. Platanias is one of the most human persons, human, and person with humility, love, and I don't know what else to say. We are close friends. We love him in Chicago, and as some of you know, some of us in Chicago are actually led by a lady most of you know, Eleni Bousis, who is a board member of Leadership 100. We have formed a foundation, the Hippocratic Cancer Foundation, something like that, I forget the exact name, and we raise money every year for his personal research. And we are so grateful to him, grateful to all of those that support the foundation. And again, most importantly, Dr. Platanias, you know that, I don't have to tell you. Marianthi thinks and talks to you probably more often. She gets more comfort from you than anyone else in the world. So, Dr. Platanias, with that, please come and join us.
Good afternoon. First of all, I want to thank Jim and for his very kind words, and I want to thank the board and His Eminency for the invitation here. I'm deeply honored. So, I was I'm going to tell you a little bit about my story and how cancer medicine was developing at the same time. So I was born in Athens, Greece, and you can see Athens here. It's a great city. So I grew up there as a kid. My father was from a town outside Agrinio, and my mother from Kefalonia. So I'm the only Greek not from Peloponnese in the US, I guess. So, but my grandfather, who had the same name with me, based on the Greek tradition, Leonidas Constantine Platanias, he was a priest. He was a priest in a small town outside of Agrinio, Lepenou, and I never got to meet him. I never got to meet him because he died, before I was born. But the stories I heard about him were truly remarkable. He was the priest of the town. He was raising money, giving food to poor people. He was going out of his way. He was someone deeply loved. And although I never met him, I have been told that I have inherited something from him, his wisdom, and I feel it sometimes. So anyway, that's how it started. Then I grew up in Athens, as I said, and I grew up in this part, I don't know if from people who are from Athens. This is the Patission area, it's Koliatsou Square. Those days it used to be an amazing place, not anymore so much, but it was great growing up there. And I went to this high school, the Ogdon, the 8th School of Athens. That was a public free school. And it was, I was hearing then that it was famous because some famous people graduated from there, including the past president, Prime Minister of Greece, Kostas Karamanlis, the previous one, the original one. So I grew up there, and then I decided I wanted to be a doctor. So I worked hard to get into medical school, and I was admitted at the University of Patras in Greece. So Patras is a city that some of you know. There is a boat that goes directly from Patras to Italy. It's across Italy, the Bari boat there. And I was actually one of the first students in that new medical school at the time. So while I was in medical school there, you can see here my parents. It's my mother and my father, and then my father with me in high school, I think. So my father was diagnosed, I was a third-year medical student, and he was diagnosed with a form of leukemia, chronic lymphocytic leukemia. And, that's what drove me to be in the oncology field. That's when I decided I need to be in cancer research. So my father had a leukemia for which there were not many drugs those days. He had a relatively slow progressing leukemia. He lived 7 years with that disease. He will have lived over 20, 25 years these days with the new treatments. But I was I was a student. I was obviously very shocked to have that. And I was trying to figure out, is there anything I could do? And there was not much, but I remember one day talking to another student who was there with me, and he told me there is a drug called interferon. And this drug, he told me it was just in Time magazine, and here it was. This drug may cure cancer. So but you cannot get it. It's only in America you can go to get this drug. So it is a long story with interferon. That's where my work is right now, and I'm going to mention some things. It didn't cure cancer, but it opened a field that has resulted in many cures. So after that, one interesting event, and you will see a follow-up of that later, I was doing when I came up for my clinical rotations, my father's doctors were in this hospital, Evangelismos. They were the blood doctors. So I asked them to rotate with them, to do my first clinical rotations with them. And they were great people, really good doctors. And one day, it was my first day to see a patient there. So I walked in one of these rooms, and before I walked there, the doctor told me, You will be shocked when you go to see this patient. That was the first patient I will see with a blood cancer. I told him, why? He goes, is a very beautiful woman who is very young. She has chronic myeloid leukemia in blast crisis, and she's going to die. And I said, what are you talking about? Why she's going to die? He said, there is no treatment. So I walked in the room. I talked to her. She was beautiful and very nice, and she told me, can you do something to help me? I said, she told me, I have 2 young kids, and I cannot get a bone marrow transplant. That was the only hope those days, because I don't have a match. And I know you're not a big doctor, but is there any way you can talk to try to help me? I have young kids. So I went out back to the attending, and I told him, come on, we must be able to do something more. He said, absolutely not. Sorry, nothing we can do. She's going to die. And in fact, that happened. She died a few months later, and I heard about it, and I was heartbroken, but she died. And her 2 young kids lost their mother. So remember that, because I'm going to come back to this. That was around 1980. So as all these things were happening, so I decided it was about time to find a way to come to the US. Actually, before I came here, I tried to go to England, and they wouldn't accept me, whatever. So England and even Australia, they wouldn't take. So, and by accident, and I'm going to show you the person who helped me do that, I came in the US, because the US is the most open country to scientists, to immigrants, and that's why it's such a great country. So I was very lucky to go to the National Institutes of Health. And that's in Bethesda, Maryland, close to Washington. That's a lot of the big research that goes on there. And those days, it was even a bigger deal. So here I am. That's now year 1984. And you can see me on the far right, 2 months after I came in this country. I could barely speak English. I could not understand most of the things they would tell me. But I was very enthusiastic. And as you can see from my shirt, I had spilled something on me. I don't know if you can see it. Or I spilled something in the picture later. But the person in the middle is this. I don't know, that doesn't work. In the middle is Neil Young. He was the person in whose lab I was working. He was an expert in bone marrow failure, in aplastic anemia. He is actually the world's expert on that for many years, and he still is. Between me and him was a professor from Patras, Nick Zumbos, and he was the person who helped me get here. I wouldn't be here if it wasn't for him, and if not accidentally meeting at him at an event when I asked him to help me, and he did. So it was for me a remarkable experience working with that group. Now with my boss, Neil Young, who, I started my career, we are good friends now. You can see us now here 32 years later in the hematology meetings in San Diego. And he has really created many of the treatments that we use right now when the bone marrow goes down. There are many drugs that he developed. So at that time I was working, you remember the interferon, and his lab was working on the interferons, on the interferon also, but in a different way. He was trying to find how this suppresses the bone marrow, because interferons suppress the bone marrow. And I was working in that lab, and the interferons have a history going back in the 50s. These are 2 scientists who discovered the interferons. Arlie Isaacs was a British scientist, and Jean Linderman, a Swiss. And you can see them working in the lab here when they discovered the interferon. As you can see, they had very few equipment, but they discovered this substance that gave a lot of hope, as you will see later, for the treatment of cancer and other diseases. So I was working there, and I was working to understand how, because interferons were suppressing the bone marrow, how that happens, and we had published some papers in that field. And then one day, Neil Young came to me and he told me, I want you to do a very special project. I want you to, there is someone here who is trying a new treatment for cancer, and I want us, but the patients, their blood counts go low. I want you to measure the human progenitors in their blood. So, and here is a paper that came those days. And that person was Steve Rosenberg, and you can see him here. Those days, that was one of the biggest breakthroughs that was going on. It was the first time he had developed this special immunotherapy that he could take cells from the patients that Ted mentioned and then put them back after he made them stronger. And there were very few patients who had completely terminal cancer. Everything had stopped working, and they got cured. Now, we're talking about small numbers, 2%, 3%. But it was a big deal. You know, all of a sudden we realized that the immune system could completely cure some people. So these were the tumor-infiltrating lymphocytes, as they call them. It was time for me to do my clinical residency, and I moved to New York. And you can see me there. I was an intern and a resident in a place in New York City, the State University of New York, in the peak of the AIDS epidemic. That was like a war zone those days. You know, there were many patients with AIDS. There were no treatments, nothing we could do. But I trained very well. You were, getting the best possible training there. So after that, after I finished that, I moved to Chicago to do my fellowship at the University of Chicago. And you can see me here when I was a fellow. So that's where I trained to become an oncologist. And during that time, there was this amazing woman, Janet Rowley, who was at the University of Chicago, and I worked in her extended group, going back to the chronic myeloid leukemia that the woman had in the clinic. Janet Rowley had described years before the molecular abnormality, and she had identified that. It was, and she died later. But she has been a very historic figure, and I was lucky to interact with her. Now, cancer, I'm not going to go back. Ted already covered many things. I just want to mention that cancer goes back to the ancient times. Cancer exists for thousands of years and still is here, and that says something. Other diseases have been cured. Cancer has not. But we can, and we should cure it. It's just not easy. So the treatments, there have been radiation therapy going back in the 1800s. Then we had chemotherapy. And in fact, I want to go back one thing. I want to mention here. There was one Greek guy, George Kanellos, was among the original, together with DeVita and others in Boston, who developed the first regimens that cured many people with lymphoma chemotherapy. So anyway, then we had bone marrow transplants. It was developed by these two people, Georges Mathey in France, and then there was a Nobel Prize in Seattle to Thomas. But you heard the immunotherapy business from Ted. Ted mentioned this Cooley event that gives a hint that the immune system can fight cancer for the first time. And I mentioned about Rosenberg. Now Rosenberg, you can see him here now at a later age. He's still active this moment at NIH. And last week, this treatment got FDA approval, a modified version. This week, remember, from the 80s to this week. And then he got the Medal of Honor, the Presidential Medal of Honor, and that's very recent. So while all that was going on, then I finished my fellowship and I got a job. And I was doing research, again, trying now to understand how cancer happens, how the immune system works at the University of Illinois. And at that time, I was collaborating with a gentleman, and we had published several papers together, named Brian Drucker, who was at Oregon, at the university. He was at Harvard, and then he had gone to Oregon. And he and I had some close collaborations But one day we were on the phone. I remember that like it was yesterday. And he told me, we have a new drug that we're going to try it to treat chronic myeloid leukemia. And that's, again, the original patient that I had seen. And he said, we know that because it's a molecular target. I told him, what's the name of the drug? He goes, it is Gleevec. So, we have the company now, and we're going to do the trial. I told him, why are you doing this? This is not going to work, you know that. So he says, yeah, I don't think it's going to work either. But we have to give it a try, just in case. Well, not only it worked, and he became a big superstar, this drug has saved now hundreds of thousands of people all over the world. It was the first precision medicine that cured, it didn't cure, but it controlled. It made like a disease that was completely fatal to be like treatment of diabetes, or even better. So amazing. All of a sudden, I realized this woman that I had met in medical school, who died young, will be alive today, then, if she had lived a few years later, a few decades later. The importance of research. So I don't want to, keep going, but right now I'm the director of the Cancer Center, of the Lurie Cancer Center at Northwestern in Chicago, and we try to do a lot of research there because we realize that research is extremely important. It's what cures people. Now, there is a long tradition there, big history. The treatment for choriocarcinoma that Ted mentioned, there was a gynecologist there many years before me who had started that treatment. And, there have been some significant discoveries. I became a director in 2014, about 10 years now. And we have seen a lot of growth since then. But what we're trying to do is to bring new treatments. That's all we care. So we have our mission as a cancer center. I'm going to skip this. But we have some unique strengths there that we try to take advantage. We had a person who is a member of the Cancer Center who got the Nobel Prize in Chemistry in 2017 for some discoveries. And we have some unique strengths in physics, nanotechnology, chemistry, and we try to take advantage of that to bring it to the cancer field, and we work hard on that. So one example is we recruited this doctor from the University of Toronto, and she brought one of these big Chan Zuckerberg hubs there. That was a big deal for the city of Chicago and many others. And we have leaders that are strong in many clinical fields so we have both some unique basic science, difficult to find, and very strong clinical leaders. And we have pipelines that we try to bring the drugs from the lab to the clinic. That's the most difficult thing to do, to start from a basic discovery and to bring it to the clinic. But when you do that, that's when you come with breakthroughs that save lives.
I had reached my lifetime max of the chemotherapy I had in my initial treatment, so we had to do something different. And she did say, if this does not work, there's a clinical trial that should be opening up, very, very soon.
At one point, Dr. Flom told me that I qualified for a clinical trial.
Because standard treatment was not going to save me.
To get to the point of breakthroughs in cancer treatment, you need to think outside the box. So at the Lurie Cancer Center, we have created the infrastructure and the process for that, and we work day and night towards this goal.
We're curing more cancers. We are prolonging life for many more cancers. And all of that did not happen accidentally, and it didn't happen because of wishful thinking. It happened because of clinical trials.
What is it? Is it something new?
What would be expected of me?
How many people have done this? This was my chance, and I took that chance.
I did not want to go through any more chemo.
I'm in. There was no hesitation after that.
clinical trials are the final stage of a careful and well thought out and long research process.
Every single treatment that we use today, from very simple things like aspirin up to the most complicated cancer regimens, were in a clinical trial at some point. So that's the importance of research, and that's why philanthropy, by the way, is why it's so important, because philanthropy is what makes this research possible and why we have the drugs we use at all levels today, not just in oncology. Here is a list, and we have a very active program there. Over the last 5 years, we had 17 FDA approvals, drugs that made it, and they are used right now, either driven by some of our investigators or with their strong participation. So clinical trials are a big deal, and that's something we focus a lot. But at the same time, we try to develop new ways, and that's the future of medicine, I believe. A couple of examples I'm going to show you, where we try to come up with completely new things. And this young kid over there, who is in our cancer center, came up with an extraordinary idea. He uses the bacteria of the gastrointestinal system. He modifies them molecularly to detect disease. There are some precancerous forms that can become cancer, and he found a way to modify the bacteria in the system and then measure the development of cancer. So in the future, there will be no colonoscopy, no endoscopies. It will be all done by doing a simple test based on that. And so remember this is going to be one day something very big.
To not only understand bacterial community biology, including the microbiome, but then even potentially re-engineer it or change it in a beneficial way to mitigate human disease or environmental pollution or toxin production.
Oh, let me go back. But something else very significant is what I'm going to talk about now. Ted mentioned about CAR Ts, which is taking cells, train the cells to go and attack the cancer and giving them back to patients. That's something that we use very successfully these days for a couple of diseases, for leukemia and lymphoma. They don't work so far in solid tumors. And this is a big hope there. There are many clinical trials, but we have not seen anything dramatic there. So there was one person at Northwestern who, came up with a radical idea. There is a disease called T-cell lymphoma, TALL, and there is a molecular abnormality that makes the T cells leukemic. The leukemia cells are super strong. So T cells are the cells of the immune system. When you get leukemia, these cells go out of control because of molecular changes. So he came up with this great idea of why don't we try to use the strength of the leukemia to create supercharged T cells that can attack the solid tumors. And that's an extremely radical idea. He published it right now in Nature. That's the best, as high as you can get. And if we can put the video where he's talking.
So I'm a physician scientist, and I see patients in clinic with these T-cell lymphomas. And in the lab for the past 10 years, I've been studying about what makes these T-cells in the T-cell lymphomas so strong. And we've been interested because 90% of all cancers are actually not T-cell lymphomas. And for these cancers, the immunotherapies don't work that well. So we thought that if we could take the superpower from the T-cell lymphomas and use them to supercharge the immunotherapies, we'd have a fighting chance to cure these other cancers. The main finding from our most recent publication, Nature, is that we found this one molecule, CARD11 PIK3R3, which gives T cells this amazing superpower to be able to survive and even to thrive in the tumor microenvironment, which enables them to actually cure multiple cancers that were otherwise incurable in mice, including stomach cancer, skin cancer, and many types of leukemia.
So that's what he did. He created a completely new treatment. That's not at the human level now, but is 100 times more potent than what the regular CAR T cells do, the approved treatments. And he's trying very hard. We're trying right now it's a very big deal to bring it to humans, but we're trying right now to create the infrastructure to bring this to the clinic, to do clinical trials for this type of thing. So, and I'm gonna finish with here, with one, I'm gonna finish with talking about checkpoint inhibitors that Ted also talked. So the 2018 Nobel Prize in Medicine went to these two gentlemen who discovered that the immune system has some brakes. You know, when the immune system is activated, there are some natural brakes that stop it from attacking everything else. The immune system is super powerful, and these checkpoints block the immune system from attacking its own body. So these guys who got the Nobel Prize said after they discovered it, they created what we call checkpoint inhibitors, which is taking off the brakes and allowing the immune system to go very strong against cancers. Now, the problem with this is that, as Ted mentioned, only 20% of the time it works. 80% it does not. And also when it works, it also has toxicities because you have an unleashed immune system in a non-specific way. So, and actually, you know, this guy, Jim Allison, was visiting us a couple of years ago, and we were talking about it. He himself is trying to address that. So we have found, and this is work that we're doing with the help of the Hippocratic Foundation, we have found a group of genes that called SLAFEN. And SLAFENs in German means sleeping. These genes, nobody knew before, but we first realized that they are activated by the interferon system. And what we have found is that when we knock these genes down, when we use CRISPR in the lab, we have activity in two tumors that normally don't respond to immunotherapy, in brain tumors and pancreas cancers. Checkpoint inhibitors work in many tumors to some degree, but they don't work in these two tumors. So what we believe is going on, we believe that these genes are what we call intracellular immune checkpoints, that they are the same brakes that they discovered, but they are hidden within the cell. The other checkpoints are in the surface of the cells. These are hidden within the cells. So that's what we're working right now, trying to develop drugs that we block this. We think that if we block this, we will have a completely new class of drugs that will have activity. And I think I'm going to stop here. I want to thank you again for the honor to let me speak here. And I'm grateful for everything. Thank you.